In the last video, we created roof plan. Now from this, we'll create multi-level. So what you will do, just go to modify data and say select window. And for multi, we have to take this thing up. So I just click on this and I'll say edit, copy, select to new plan. So new plan has been selected. Now, what I'll be doing here, this is a ordinary slab. So I'm going to change the loading for that. So I say slab data, select all, and I'm assigning normal load. Means I'm doing extra load, and there will be extra load of waterproofing. So this I'm keeping as 2, and I said okay. And on this external wall, there'll be a simple wall of about 300 mm. So what I'm doing, I say beam data, select external beam, and I'm saying assign the load of say freestanding wall of say 0.3 meter. Okay, okay. Then I say run, and I also say file save as mumty, mumty, mum mumty. Okay, I said save. So first, sorry, I have to say run and save. So I've saved this. Now I want to create a plinth level plan. So what I'll be doing, file, and I'm calling this typical plan. And from this, I'll create, from this I'm going to create plinth plan. So I'll say file, save as plinth, P-L-I-N-T-H, plinth. I'll save this. So this is saved as a plinth. Now suppose on the plinth, my wall height here, if you see my okay, wall height was given as a 3. So suppose from plane to plan the height is 3.5 meter. So what I'll do, I change this thing to 3.5 meter, and I don't want any slab here. Okay, all the loads would go directly to the ground. So I say slab data, select all, right click, delete selection. So I'm deleting 9 slab. Now here my flow rate has increased. So first what I'm doing is a column none. So now flow rate has increased. So this also would go up. Load will go up. So what I'll do, I just go to beam data and I say select by property. So I'm selecting all the beam who are more than 12 meter, 12 kilonewton. So I click on this and I say more than say 12. So now it has selected all the beam which are more than 12. So now what I'll do, I just say assign UDL. Now see my height has become 3.5. So wall height is wall height should be 1 second. It's not a freestanding wall. So it is 3.5 minus zero point 0.9. So let's see if I can write equation. No, I cannot. So 3.5 into 0.8 is about 2.6. So I say 2.6. No, it's not taken. Actually, it should have taken. Suppose here I go and instead of freestanding wall of I say 2.6. Okay. Then wall thickness this. So these are the loading. I said okay. Okay, so load has become 13.95, and here uh, uh, again the load would change because of change in fluoride. So now, okay, what I'll do, I just go here and I said uh, beam data. First I'll say unselect all the beam, then I'll say beam data, select by property, and here I say select all the beam which are less than say 9 kilometer. No, sorry, uh, I've selected wrong. So UDL which is less than 9. So it will select all this. I said okay. So it is selected all the beam which are less than this. Now again I'll go and say assign UDL. So he- here I just go and say freestanding wall of 2.6 meter. Okay. Okay. So now this load has changed to 8.805. Right. So this way I've created complete clean plan. So I'll say run it. So see there are no load on the slab. I said okay and I said save. So my plinth level has been saved. So this way I have created four plans and I can see each one of them. This was my multi plan, then this was my roof plan, then this is typical plan, and this is my plain plan. And plain plan. Okay. So now what I'm going to do is I'm going to create a complete frame which will consist of seven levels. So what I'm going to do, I just say file, I say launch Framewin, and there are seven levels. So top level I'll take from empty, from this I'll take from the roof, then this I'll take from plinth, and this I'll copy down this. No, sorry, this is typical. I'll copy it down, and the plinth 01 is a plinth level. Okay. Now these are now so grade of concrete. I want to use say 25. So I say this is the grade. These are the load reduction. I said okay. And to this I'm giving a name say frame ETIPS. I'm going to create ETIP first. I say save. So this is my first level, second level, and this is my multi level. So now here you see that these beams are broken, B2, B3, because in the state this beam has to be broken. But I'm creating ETF file. So what I will do, I just go here, I say edit level information, and I'll remove this, create full frame. So now this beam is a one beam and these are the secondary beam. Secondary beam are one which are not between the columns, or there is only one column. So these are the secondary beam. So load will get transferred anyway. Now the first thing I want to create a shear wall. So what I'll do, I say assign shear wall, and I'll click between these two, and suppose my width is zero point 0.2. Again I'll create here. Okay. Again I'll create here. Then fourth wall. Okay, and this is my this wall. So I've created shear wall. Now column size. Now just now I just know the vertical loads. So what I'll do, I go to say assign column sizing and I say auto size. And here what I'm saying, take the extra load of about say 20%. This is just to allow because column size would increase because of seismic and wind. So from my own judgment, I'm assuming there will be 20% extra load I have to give, then size will be proper. So and then suppose here for first three level I want to column size same, and then here I want fourth to seventh I want same size. So I said auto design. So now you see that first three levels these are the size, and for this it is zero point 0.3, and if I click on this, so these are my LF1, right? So this was the shear wall here. So I said now suppose now I have to give okay this one direction. So suppose this I'm keeping next direction. This I want y direction. So I click here. Then again this I want to align like this. Here I want to align like this. Here I want in y direction. Here again I want in y direction. This I want in y direction. This also I want in y direction. This I want in y direction. This y direction. These are the shear walls, and these I want to keep x direction, these two walls. So I have given the direction, I said close. So these are the column. Now suppose for some reason these are the corner column which will have less load, but there will be more this one bending moment, and I want to increase this size as per my own judgment. So I'll just go here again. I said assign column sizing, and now suppose here if I go and I want to change the size, so I click on size, and suppose instead of 4.5 I want to have zero point 0.6, and I want to copy till three levels, and then here I want size of point say 4.5. So this size is increased, and I want to copy this size at each corner column. So I say paste, paste, and the paste. So this way I have decided preliminary column size. Now I want to assign wind parameter. So I go to wind parameter. I select the city. So it takes the wind speed and whichever terrain I want. And height below ground, there would not be wind load, and on parapet there is wind load of 1. So this has been wind load has been given. Now I go to assign seismic. Again seismic, I can give whether I want uh, factor 3 or 5 or what, okay, whatever I want. Right now I'm keeping say 3, and the time period it works out without brick wall, with brick wall. So I'm taking with brick wall, said okay. So my this all the data which is required for ETFs are there. Next thing what I'm going to do, I said analyze, generate. So suppose I'm generating E2K file, and all other I'm getting, and I'm saying view the input file. So it has created ETF file with about 2000 lines. So these are all the ETF file has been created within less than some 2 seconds, and it contains all the information what are required to generate ETF file. So next what I'm going to do, edit. So ETF file is being generated. So what we'll be doing in the next video, we'll open up that file, uh, execute it, and then we'll go for using Planwin to create the drawings. Thank you so much. This is the end of this video.